Hello and welcome to another tutorial. So this time around we are going to be building a new sensor system. So sensors are how AIs actually gain an awareness of things in the world. So common sensors that we'll see in games are usually vision, hearing, and also often proximity. You might have different sensors depending upon your particular game. Some characters might have, one sense, others might have different ones, so there's a different mix that you might have there. So I've previously set up ones for this before, and they worked okay, but they weren't sort of super well designed for being able to easily swap in your own sensors and to sort of mess with things like that. They were also very tightly coupled to the code logic. So what I'm wanting to do with this is set up something that is a bit more standalone. So I am going to be implementing this in the AI behaviors package, and it is going to be a replacement for the sensor system there. But it is also going to be something that's more decoupled from the rest of the sort of logic there. It's also going to be structured in a way where we have a lot more control over the performance of it. So how it's going to work is there will be a central perception manager. That central perception manager is going to then drive the actual updating of perception for everything else. So it's going to, each AI will have the sensors on it and they will have an associated configuration. And then that perception manager is going to have those different sensors, it's going to run them and swap in, okay, now go and evaluate using this vision configuration. Okay, now with this other vision configuration. So it's going to make it a little bit easier for us managing performance if we're needing to sort of centrally control that in the future. So that's going to be the structure that we go for with it. Now there is quite a lot that we need to set up because this is quite an involved infrastructure. So likely this is going to be spread across a couple of videos. Now the way I'll set this up is that in the description you'll find a few links. There will be a link to the code as it currently is when I'm about to start writing this code for this tutorial, and then there will be a link to the code at the end of it. And then there will be a link to the full AI behaviors package. So all three links will be there. If you're wanting to know how to work with any of the other sections of the AI behaviors package, there's a playlist that I've linked to it that has all of the other sections there in the video. Okay, so let's dive on in. So a couple of things to sort of note with this that are important. So one of the things that I have added in separately, I haven't covered this in a standalone tutorial because it's quite a small sort of self-contained thing, is I've created this thing called a serializable type. So what this is this is a version of, or essentially a wrapper around a system.type that we can actually use in the inspector and that we can actually serialize out. So what this allows for is when we use it, we say, okay, I want a serializable type, and you give this type here, and that what it will do is in the inspector, you'll get a drop down that only shows the concrete, so the non-abstract versions of any child classes based on that type. So that's something that I've added into this that just makes it really sort of handy for working with. So, okay, we need to start looking at the different things to set up for this. Now, there is quite a bit that we need to build. And one of the things that I actually want to set up to begin with is actually a faction system. And the reason for this is, so when we're doing perception of stuff, the way that we react, an AI reacts to a player isn't necessarily how an AI might react to another AI, and we might need them to be able to perceive them. So what I want to do is I want to actually set up a very simple faction system but one that's going to give us a bit of flexibility for in the future if we're wanting to add further things to this. So I'm going to create a data folder, and I'm going to create a folder for our scripts. So I'm going to create a couple of scripts here to begin with. So as I've done with a lot of things, I'm going to have an interface IFaction. This will allow me to easily sort of wrap things. That's going to make stuff a lot easier. I'm going to create a faction component script. So the idea is that will be what we attach onto something to give it a faction. And then I want to have a data asset it'll end up being, which will be a faction definition. This is going to be essentially the defaults for a particular faction of what it actually does. So I'm going to set up the faction definition first. So this is going to be a scriptable object. So just a simple scriptable object. We will set up our create asset menu, menu name, and we'll just put this similar to what we've done for the other ones under this parent AI menu. And then we'll have a faction definition like that. And our default file name will just be faction. So that's good. So, okay, a faction is going to have a couple of sort of properties to this. So I want these to be things that can be accessed externally but aren't able to be modified. So this is where I'm going to make these properties. So public string display name, and this is going to be a get, but a private. Actually, I'll make it protected just in case we have a reason to override this in the future. So if you haven't seen this syntax before, what this does is this applies this attribute to the backing field of this property. So it's a really handy way of having something that is serialized, that's exposed in the inspector, but that can't be actually modified externally by other things. So really, really handy sort of setup for it. So then, okay, I want to have as defaults be able to define, okay, how does this faction feel about other factions? So what I actually need here is a system serializable, and we'll have a class for faction standing, and then that internally is going to have, again, that same process of that serialized field, and we will have our faction definition, other faction. Should I just call it other? No, other faction works. And our usual get and protected set. Now I want to define what that relationship actually is. So I'm going to up here create an enum, and this is our faction relationship. So we'll have friendly, neutral, hostile, and unknown. But I might not want unknown to be visible in the inspector. So I can actually do this, and what we should see is that unknown can't actually be seen in the inspector, which will be really handy. So we have our field here. This is our faction relationship. So our relationship like that. So that's good. And then all we have here is a list of our faction standings, and this is going to be our default relationships. And again, a get and a protected set, like that. We make that public. So let's get those created, just so we've got those data assets set up. So we should be able to go to AI and factions, and then our faction definition. So faction AI. So display name is AI. Default relationships, well, we have relationship to other AI. So we can see it hasn't actually filtered out unknown. So unfortunately, that is one where, although that was claimed to work, it unfortunately doesn't, but that's all right. So we've defined that one, and then we will create another faction definition, faction player. So this will have two entries. So we will have the AI and the player. So towards the player, so the player standing towards the AI will be hostile, whereas player to player will be friendly. And then for the AI one, we add in player and make it hostile. So that's good. We've got our setup there defining those particular factions. Now what we can do is we can start to get stuff like our interface set up and some of the other key bits that we need for this so that we can make this all work. So iFaction, unsurprisingly, if you've seen the previous video, is going to be a locatable service. So anything that implements this iFaction interface, part of its job is being able to tell you what faction something is. So it needs to be a locatable service. So now that we can define this interface, there's not too much that it actually needs to do. There's just a couple of key essential things that it's going to need to be able to answer. So one of the things is I do want it to be able to provide back the faction definition, like that, but I only want that to be a get. And I also want it to be able to give me back the faction relationship. In particular, I want to be able to say, okay, give me the relationship to, and then provide it with another faction. So that's sort of the key things I want it to be able to do. Now there are further things we could add in future, but for now, that's sort of the essential things that we need. So this means we can get our faction component set up there. So the faction component, the goal for that is to be keeping track of, okay, what is the current faction, all of those sort of bits and pieces. So it's going to implement iFaction. Now that's going to come with a couple of sort of things that we need to actually do then. So one of the things is this needs to have configured on it the actual faction definition. So we're going to have our serialized field, public faction definition. Now with this, we're actually overriding that property that we defined in iFaction. So you can, when we're implementing a property from a interface, there's nothing stopping us from making that also be serialized. So that is a thing that we can actually do. So that's good. What I want to then do is also set up stuff here like, okay, well in awake, I want to say, okay, service locator, I want to register as an iFaction, and I want to register ourselves and the context is the game object that we are attached to. So that's just going to make it discoverable. We also have this faction relationship where we can get the relationship to. Which initially I'm just going to make that return unknown. So that's fully implemented the interface now. Now what I'm going to do is I'm also going to create a list here of faction. We'll have this as B. It will be faction definition, faction standings, and this will be the current standings. And I want to explicitly say that that is null. Then I will have a public list, faction definition, faction standing, current standing. So I'm setting up a property that what it's going to do is, at the moment we just have a getter, but this allows us to, we will have the default standings, but then we can come and modify them later. So, okay, returning the current standings is going to be the norm, but if current standings is null, then what I want to do is current standings is newly created, and then I go through for each var standing in definition, default relationships. So I'm doing this so that it creates a deep copy. And I would do current standings add. So then what I want to do is create a new one and just pass in the other standing for it to create a deep copy of, which if I go to that faction standing, and what we're going to do is give this a constructor, and in other, like that, and then we just have other faction equal to in other, like that. So that looks good. That just gives us an easy way for creating that deep copy. Now, for getting the actual relationship to something else, well, that's also pretty straightforward. Going to just loop through, and then this is going to be in R. So we'll call that standing in current standings. And what we are looking for is if the standing dot other faction is equal to that faction definition. If it is, then we return standing relationship. So it just gives us a way of, we have this faction component we can attach onto things and then say, okay, well, this is now a AI faction, different things like of that. So onto our hybrid gope one here, I can add our faction component, and I'm going to just say that it's an AI. Similarly, for the player, I'm going to add a faction component, and I'm going to set that to player. So now our AI and our players both have faction information, so they can make use of that in terms of in the perception system. So that's good. We've got our faction side of things set up. We have those bits ready to be actually working with. What we can now start doing is actually building our sensor system. So what I'm going to do is create another folder here. And this is going to be perception. So then under our perception system, now there's going to be quite a lot of files we actually have. So we're going to have a folder for data. That's where things like our sensor configurations are going to live. We're going to have a folder for scripts. Now that's going to have a few different ones under it. For one thing, there's going to be a folder of sensors. So that's going to be in there. And then there's going to be a lot of different things we need to get set up. So let's start to look at the different things we need to get set up. So one of the big things is there's going to be a lot of interfaces. And there's going to be a heap that we set up. And the reason we're doing this is, again, same process that I'm following with a lot of these things, is using interfaces to heavily decouple the particular systems. So one of the things is we're going to have something that is perceivable. So there'll be a specific interface every perceivable thing has to implement. I want to also have a listener, so something that's actually and I'm calling it a perception listener. The reason being that iListener feels like something that quite easily there could be other implementations of. So we'll have something that's perceivable, something that's listening for perception information. We're also going to, for our actual perception manager, because we want that to be discoverable, I'm going to have a IPerceptionManager. And our sensors themselves actually need an interface too. Again, I want to keep the sensors super generic. So, okay, that gives us our key set of interfaces. So we're going to get these populated first, because these are really defining what our actual sort of logic is going to look like. But I will do the initial converting of all of these things to an interface, just so we've actually got that from the very beginning. I'll potentially also end up adding into this project my setup for predefined templates. So I think that could be really handy to have. So we've got all of our interfaces defined. So let's start with getting a couple of key things implemented for these. So for something that's perceivable, there are a couple of key sort of questions this is going to need to be able to answer. One of the things is, and we don't actually need to explicitly make this public, we're going to need to be able to get the position, like that. I want to be able to get other information about it, so like its velocity. I want to potentially also get other information like how it's moving. I might have a simplified version of that. We could infer that from velocity, but it would be kind of handy to be able to actually just have something that the system itself could just override. So whether it's moving, I want to be able to get the owner of it. I need to be able to also get its faction. Oops, not public. So IFaction, like that. So that's pretty good. We'll be able to know where it is, where it's moving, if it's moving, its owner, its faction. That's sort of a lot of the key questions we need to answer. The other thing is I want to know if it is perceivable by a particular type of sensor. So we'll have system.type in sensor type. The reason for this is we might have something where, okay, an AI is temporarily not able to react to a particular type of sensor, or it's only able to be detected by particular ones. This is going to give us an interface for being able to manage that. So that's good. Our perception listener has a bunch of common things it's going to need to be able to answer as well. So it's going to need to be able to tell us the origin point of the sensor. So where the eyes are, things like of that. We need to know the direction that it's actually facing. So sensor facing, because in particular for something like a vision, that is something that we do want to factor in. We do need owner as well. Unsurprisingly, we also want to have faction because we need to be able to determine, whether these two should actually even be able to be sensing each other. I want to have a simple way of being able to ask, okay, well, can it detect a particular perceivable thing? So that's a common thing that I want to actually have. Now, I want to also have some notifications that can come into the listener. So being able to tell it when there's a new best perceivable thing. So we want to have on notify best perceivable. So this provides the perceivable thing, provides a detection strength. Now this is something we had in our previous sensor system, this idea of giving a numerical value of how strongly have we detected something. That allows the AI to be able to react differently based upon a very low level of detection or a dropping detection versus an increasing detection. So we're doing that same logic here. And we want to also provide things like, well, okay, when did we last detect this? So last detection time, and because we might use it, our last location that we saw this. So last detection location. So that's good. Just bring this down here. Also close this so I can zoom in a little bit more. So, okay, that's good. We're notifying whatever our current best target is. I also want to be able to notify when we lost that. So lost perceivable. And we can give it the particular perceivable. So, okay, that's sort of the key things our listener needs to be able to be aware of. This will allow the listener to react to detections, to be able to override if it can detect something. So that's going to work quite well. Our perception manager, it's got to have a bunch of things as well. One thing, it has to be a locatable service. We need to be able to track down our perception manager. It needs to know when there is something that is listening for detections and when there is something that is detecting things. So this is going to have registration and deregistration functions. So there's going to be a register listener. So we have our perception listener. Now, when we register something, we want to provide the configuration for it. So that's actually another script I'm going to just create here. Sensor config base. This is going to be the base script for our sensor configurations. It'll be a scriptable object. And it will be abstract. So I'm not populating anything in there at the moment. It's really just making sure that I have everything I need for being able to set this stuff up. So when we register a listener, we also register it with a particular config. So in config, we have our deregister listener. Like that. We're also going to have similar thing for are perceivables. So we'd have a register perceivable. And just like we have the register, we would have deregister. So this just allows so that we have one thing that's keeping track of all of our listeners, all of the perceivable things. We'll fix the naming there. So that allows us to more easily sort of prioritize the particular logic that needs to happen. When I actually work with this stuff, one of the things I'm going to need to be able to answer is, okay, well, what is the detection strength? And so I want to know for a particular listener, what is its detection strength of a particular perceivable? So that will give us back, okay, how detected is this particular thing, if at all? So that's a key question that our perception system must be able to answer. The other thing is I want to be able to, feed data into this. So there's two kind of main ways I want to feed data into this. One is via sort of the normal update path. So this is reporting a detection. So this is a sensor would report a particular detection. So it's going to be a particular listener is going to report about a particular perceivable. So certain listener is going to say, okay, well, for this perceivable, I've detected something. It needs to say which sensor it's detected it via, because that might be relevant. And it also has the particular strength. So sensors don't need to report the loss of a detection, but they do need to report that there has been a detection. Now, normally, that's going to cover a lot of our use cases. But there are cases where we need to manually inject a detection. This can be really handy for opening up options for designers, being able to pull an AI's attention in a particular location, or pull an AI's attention very rapidly to something to bypass things like, you might go into an area, a cutscene might play, and you want to immediately have the AI be fully at the detection or lose detection. So I want to have also an inject detection. Now this does not have a listener. It has a perceivable and it has a sensor type. And let's fix that type. And a strength. But you'll notice that it's a little bit different, sort of the structure for this. We don't have an associated listener because this could be coming external. We don't have a sensor because, again, this could be coming outside of an AI. So we just say, okay, we want to be able to inject this for all of these particular types of sensors. And then we have the strength. So, okay, that's good. Then our final interface that we need to set up is this ISensor one. So there is going to be a bit of overlap with some of the stuff here in the Perception Manager, because when we register a listener or a perceivable, that information might also need to go to a particular sensor. So I'm going to actually grab these and I'm going to bring them over here as well. So we can register and deregister listeners, and we can also register and deregister perceivables, because I think that's actually going to be really important for us to be able to do, because some sensors are going to be very simple in what they do. Other sensors, particular vision, are quite complicated, and vision in particular can do a lot of stuff where it can take that information of listeners and perceivables and process that into a shorter list of queries that it needs to do and prioritize them. So it's an important thing for being able to have these interfaces there. Most of the sensors aren't going to need to do anything with this, but it means if they do want to, they can. Sensors are going to be tickable. So a sensor isn't going to be a monobehavior, which means we need to be able to tick it externally. So I'm going to have a tick function. It's going to get the delta time. So whenever I'm setting up something where you're essentially an update function, but it's not from a monobehavior, I always refer to it as tick, and I always pass in the delta time. Two reasons for doing these. I call it tick rather than update to make it clear that it has to be manually invoked. And I pass in the time in case in the game you're doing something that actually you want to mess with the timing of things. You might want to speed up or slow down time. So that's good. We've got our delta time. I want to also, with this, it's going to get a list of the perceivable items. So and this is our perceivables. Now there's likely going to be other things we modify in this interface. That's okay. And the perception manager is going to be handling the ticking, so it's going to pass itself in. We also want it to be able to evaluate injected detections. The reason being that we don't want an injection of a detection to entirely bypass a sensor. We actually still want the sensor to be able to do some processing on it. So if there are range limits, things like that, we still want those range limits to apply. So we have our perception listener. We have our sensor config base. We have the thing that is being perceived. And then we also have the strength. This will just evaluate and say, okay, this injected detection, if it's valid for it to be injected, then return true. Otherwise, it can reject it. It's just going to make things a lot easier for us being able to sort of work with this. So that's sort of the main reason for actually setting that up. So now what we can actually do is we can build our perception manager. That's going to be one of the big sort of core things we need to set up. So what I'm going to do is have a script here, and this is going to be our perception manager. So we'll get this set up. Now our perception manager is going to be one of our mono-behavior singletons. Don't know why Visual Studio keeps closing all of the other files whenever it does this, but it is doing this. And Visual Studio crashed. Cool. It's having a really good day, it seems. And it closed a different set of files this time. All right. So our perception manager is our mono behavior singleton. We do want this to be a concrete thing in the scene that is getting updates. Have our perception manager like that. So that's good. So there's going to be a lot of things that we need to get set up for this. There's a lot of interfaces that we need to actually create here. So let's get these interfaces and everything going first. So, okay, we need to be able to register, deregister perceivables and listeners. There's a lot of stuff that we have to keep track of. So I'm going to set up the stuff for that tracking first. So when we register a listener, it gets registered with a particular configuration. So I'm going to have a public class, and we will have a listener entry. And we're going to give this a perception listener. It's the listener. Also has a config. And so, okay, that's a particular listener. It's going to have a certain sensor configuration that's associated with it. So how we use that listener entry is we're going to have a dictionary here. And for each active sensor, we have a list of associated listeners and the particular configurations for them. So these are our active sensors. Now, alongside that, we also want to keep track of, okay, for a particular sensor, what are the perceivable things? So we're going to have a list of IPerceivable. And this is going to be our active perceivables. So, okay, we're keeping track of what are our associated listeners and their config for a particular sensor. So one sensor, like hearing, might have 10 listeners, 5 of them might have the same config, and another 5 might have a different config. That's kind of the structure we're going for with this. So we swap in and out different configs, but we've only actually got potentially one vision sensor, one hearing sensor, one proximity sensor. They just get run with different settings. So, okay, we've got those. We've got our perceivables. We also are going to be keeping track of how detected something is. So we're going to have, and this will be a protected class because we don't want other things directly accessing this. So we'll have detection data. So this will have a strength. This will have the time it was last actually detected. And it's going to have a location. The last detected location. Yeah. So that's another thing that we're going to keep track of. So we're going to have a dictionary, and this is going to be organized by our listener. And then within that, we have another dictionary that is our perceivable, and that links to the detection data. That's just going to make it very, very easy for us to be able to say, okay, for this particular listener, what is your detection of this particular thing? Or even if we wanted to grab the detection information for everything. So, okay, that's a lot of the core data that we're going to need to be storing. I'm going to set up our onAwake function. So we'll have our protected. Now, because it's a singleton, we actually have an onAwake that we can override. So our active sensors, we knew that. We do the same thing with our active perceivables and with our detection data. That's good. We've set up the links to all of those. What I'm going to also do is our service locator. We register the service and our perception manager, and we register like that, but with no context because this is a global one. So that's good. So, okay, we've got a bunch of sort of the initial setup things happening there. Now let's start to get things going in terms of our registering, deregistering of things. I'm going to actually reorganize this a bit. I don't like how with the interfaces it just goes and puts them in alphabetical order. Actually, really would much prefer it to go and use the order that I have put stuff in. So I kind of want things grouped more by their particular sort of data they're working on. But either way, it's working. So, okay, registering a listener. Let's get this up and running. So when we register a listener, we provide a configuration, and that has a sensor type in it. So if we go to our sensor config, which we haven't actually done anything with this yet, I'm going to go to the sensor config base, and the key function this is going to have is a public abstract system.type get supported sensor type. So as I mentioned, with the way the perception stuff is going to work, I only want to create one instance of each sensor type and swap in different configs. That's the way that I need it to actually be working. So first thing I need to do is check if this sensor is already present. Is this sensor already present? So we loop over. This is our sensor entry or sensor KVP in active sensors. So what I would check is, okay, our sensor is the sensor kvp.key. So I need to check if this particular type matches. So if sensor get type, if that is equal to our sensor config and our get supported sensor type. So if those match, then this sensor already exists. So this case, we know that sensor is already present. Well, we want to check, just for safety, make sure that there's not a double registration. Because if there is a double registration, that's actually a problem. So we would loop through. Now in this case, we're looping through our particular listeners. So we want to look through, and if we look at how the stuff is set up, our active sensors, we have these listener entry. So listener in sensor KVP value. Let's fix up our typo. So we want to check, does this listener already exist? So if listener, that, and I might actually rename this to listener, I'll just call it entry. So if that entry listener is this one, then we can't re-register it because it already exists. And what I should do is log out an error. So what we'd say here is in listener, and we can actually log out the owner, is attempting to register itself multiple times and we log out the sensor config. Like that. That's just going to let us report the particular error. So, okay, if it gets outside of that for each, then we know that we haven't accidentally added a double entry. So what we can do is we can say, well, sensor KVP value, we can add a new listener entry. Our listener is that, and our configuration is our sensor config. So we just register it. Now the actual sensor, we should tell it that it also got registered as well. And then we just return. So we track our listener, we let the sensor know in case it wants to do anything, and then that's good. Now we'll do similar down here, but in this case, if we get to this particular point, what that actually means is this particular sensor type doesn't actually exist yet. So we need to create a new sensor. So what we can do is our new sensor is, and we cast this to an ISensor, and we can go System, Activator, Create Instance, and what we do is we provide our InSensor config, get supported sensor type, like that. So that's good. We've created a new sensor. Then what we would do is we would say, okay, well, our active sensors, the new sensor, well, that needs to get this new list. So we need a new list of our listener entries. And we can actually give that an initial value, which this is that first entry we provide to it. So we create the new sensor and we register our listener as well. So it's a little bit involved for creating a new listener, but it does ensure that there is only one of each sensor, and it also ensures that we're picking up if we accidentally create a duplicate. So, okay, that'll give us tracking of new ones. We do need to support deregistering as well. So that's a little bit of a similar process. So we loop through our active sensors. We're going to pull out the particular values here. So our listener entries. And we actually got these around the wrong way. Should just double check up here to make sure, yes, we're using key. So, okay, what we want to do is remove any entries for this particular listener. Because a listener might have registered for multiple sensors, so as soon as we deregister it, we want to actually remove it from any of the particular ones. So we have to do our usual loop of listener entries. And so we loop backwards through things. We grab out our entry. And if that listener matches, then we can remove it. So we do a couple of things with this. One is the sensor, we tell it to deregister this particular listener. So we're keeping the sensors fully in sync. And our listener entries, we remove the one at this particular index, and then we break, because there can only be one entry for this particular listener. So as soon as we've removed it, then we can exit, which probably means we could get away without actually doing the reverse iterating, but force of habit, that is kind of the general way of sort of working with them. So that's good. Listeners can be registered and deregistered. Perceivables are the next one that we need to actually do. So with the perceivables, we need to do a few sort of things with this. I'm going to actually do the deregister first, because the deregister is a bit shorter. So this is our perceivable KVP in our active perceivables. And then what I would do here is if perceivable KVP dot value, and if we successfully remove this perceivable, so the remove function actually returns true if it removed everything. So we just actually try to remove it. We don't bother doing a lookup. And then if we did, then only in that case do we actually tell the sensor that we removed it. So it's a bit of a different way of doing this process, but it does actually, you should give us better performance. So we'd normally do a contains check, which would have to go and actually look through. We could also do a find, and that would give us the index, but either way, we're doing a check first. So we can just roll it into the remove, and then if the remove is successful, we do a deregister. Keeps the logic a little bit cleaner and neater. So now we get to registering the perceivable. So much like with the sensors, these are, well, sorry, the listeners, these are grouped by sensor. So what I'm going to do is a perceivable might need to be registered with multiple sensors. So I'm going to loop through the sensor in active sensors.keys. Now you might be thinking, well, why am I looping through active sensors keys, not our perceivables keys? The reason for this is our sensors are getting registered sort of early on, and a sensor might be registered before a perceivable has been. So what I will do is then, okay, well, this particular perceivable might not actually show up for this sensor. So I want to go and check, okay, can this be perceived by, so is perceivable by, and then we grab our sensor and get its type. If it is not perceivable by it, then we skip it. So there might be a target that can only be perceived, by a particular one. So there's no point registering it for things where it doesn't actually make sense. So, okay, we can check if the list of entries isn't already there. So if the list doesn't already exist, then build it. So we have our list of IPerceivable. And we're going to default that to null. Then what we do is we do our active perceivables and we try and get the value of this particular sensor and out that to perceivables. So if that fails, then I knew that list and I link that active perceivables. So if that fails, then my perceivables list, I actually create that. And our active perceivables gets that linked up. So that's good. We've properly instantiated that. So that means that then here, okay, are we already in the list? Again, what we're doing here is looking for errors. So if perceivables contains this particular one, then I'm going to skip it because what that means is we've tried to register it multiple times. So again, we output an error. So we're attempting to register IPerceivable owner multiple times for sensor, just like that. So we just fail out and we skip. So we allow it to register for other ones. Now with the one here, if the sensor was already present, we didn't need to re-register. We could return slightly different structure in terms of how it's working, because this one is registering something for all of the sensors. Now we could argue that that should just return and fail out everything. It's going to leave it in a messy state either way. I'm inclined to say that it should register it for as many things as it can, but I could see arguments for either way with that. So, okay, that's good. If we've then gotten to this point, then we're not already in the list. So we can go perceivables and we add it. And our sensor, we can tell it to register this particular perceivable. So, okay, that's our registration and our deregistration of the perceivables. That is actually a big chunk of the logic that we need to actually get set up. We could start to implement things here like our get detection strength. So if in listener is null, so we want to just do some safety checks here. So if the listener is null or that's null, we're just going to return -1, which I might just return float min value. So, okay, unlikely to happen, but just, as a potential. Failure case will also just return the min value. Then what I do is, okay, well, I have a dictionary, and this is our dictionary of perceivables and the detection data. Detection entries. It's null. So what I try and do is our detection data, I try to get the value for this particular listener. So if I successfully got the value, then again, we have our detection data. Don't explicitly need to set it to null, but again, force of habit from C++. So our detection entries, we would try and get the value of our perceivable, output that to data. And if we succeed, then we return data and our strength, which I'm actually going to just rename that to detection strength. So that's good for our retrieving of a detection. That will do the job that we need there. Then we have our logic here for reporting and injecting a detection. So I'm going to do the reporting of a detection first. So this has to do a little bit of a similar process to our get detection strength. We have to go and do this retrieving logic first because there might be no entry. So we try and retrieve it first. If this fails, however, this is where we do things slightly differently. If it fails, then detection entries, we knew that, and we actually just add that in. So we add in our IListener, our InListener, like that. So we check to see if that entry exists first. Then we have a similar bit of logic to this. But again, what we will do is if it's failed, then we would say that data is new, and our detection entries gets that added in. So this sort of pattern we'll see quite a bit for just ensuring that the dictionary always has logic there for it. We could do this by nesting this, but I try to actually avoid nesting our if statements as much as possible. This just keeps the code a bit flatter, and what it means is that the code after this can assume that this data is valid, and that allows me to make the code simpler. So then at the end, my code just ends up being able to be quite straightforward. So one of the things I'm going to do is I'm going to do a clamp here of our data dot detection strength plus our strength. So we keep it clamped between a 0 and a 1. We have our data last detection location, IPerceivable position, and we want to keep track of the time. Now, what I'm going to do for this is I'm actually, oops, not that, is I'm going to create a property up the top here that's just going to be a public float current time, which for now just maps to time.time. The reason I've done that is because we might want to have some other way of working with the time, and having this global to perception sense of time that we can refer back to, something that it's anchored with, is going to make things a lot easier for us being able to work with that. So while there's no immediate need for it, it's a little bit of future proofing for what we actually want to do. So, okay, then we've got our injecting of detections. So our detection injection, we do want the sensors to be able to do some processing of this. If we remember, in the particular sensors, if we go to the logic here, we had this evaluating of an injected detection. So we want to support that. So what I would be doing is in our inject detection, I'm going to loop through, and this is going to be our sensor KVP in our active sensors. So the reason being is I want to be able to access the configuration, stuff like of that. So we're going to have sensor. So that's our sensor KVP, and that's the key of that. So, okay, if this particular sensor type doesn't match, then we shouldn't do anything with it. So if the sensor will skip if the type doesn't match. So if, and we check our sensors type, if that is not equal to the one that's been provided, we skip it, because the injection only happens for particular type. So then we let each sensor evaluate if it should actually go through. So now each sensor to determine if we use the detection. So what I would say is our listener entries, that is our sensor KVP value, and we loop through those. And then what I would do is, okay, well, if our particular sensor, and we evaluate injected detection, we have our entry and the listener. We have the entry configuration. We have the perceivable. And although we're not making any use of it, we're still going to provide the strength, just in case we do want to make any use of it. So if that returns true, that means the sensor has said this detection is valid for you to inject. So we will just do a report detection, and we have entry listener, IPerceivable, sensor, and the strength. So this just allows us to, we can inject a detection that gives us more flexibility in that regard, but it still has to go through our normal reporting logic for ensuring the ranges. And it also lets each sensor do some checks on it so that if it is too far out of range, things like of that, we can still reject it. So we can manually inject the data, but there's still processing and sanity checks that are going to happen as part of that. And I think that's really important. Now we're nearly done with getting the Perception Manager set up. The couple of main things that I'm going to do as a remaining sort of setup is I'm going to give this a bootstrapper to always create it. So this is our Perception Manager bootstrapper, just so that we don't need to always be adding it into a particular scene. So we have our runtime initialize on load. Our type here, we're going to say after scene load. Have our initialize, and what we do is similar to what we've done for other ones. If our Perception Manager instance is not equal to null, then we just run Perception Manager instance and then bootstrapped like that. So our Perception Manager is now always going to be created. We've got our registration, deregistration. Like I said, this will be a tutorial in a couple of parts. The actual sensors themselves we will implement as a second stage. But there is one big remaining thing that we do want to set up in this, and that is our update function, because the sensors need to be able to be ticked. So what I'm going to do, and I'll do this up the top here. So we're going to have our protected void update. So this has got to do a couple of things. First thing we want to do is we want to do any ticking of sensors. So stage 1, tick any active sensors. So pretty straightforward. We have our sensor AVP in active sensors. We have our sensor, and we have our listener entries. So what I want to be able to do is firstly get all of the perceivables for this. So I want to have a list of IPerceivable, and this is a set of ones. So we'll default that to null. So if there are no perceivable things for this particular listener, then there's nothing we actually need to do. So if we fail this logic here for trying to get the particular value, so we look for our sensor and our perceivables. If that fails, we just continue because there's no perceivables for that sensor currently active. If there is, then what I want to do is go sensor, or tick. We give it the delta time, which in this case is just time delta time. I want to give it those perceivables, give it the Perception Manager. I also actually want to give it these listener entries, because that's something that I think is going to be potentially useful for it to have at times. So what I will do is in our sensor here, allow this to in listener entries, and this is just going to be Perception Manager. So this does break things a little bit in terms of having a particular class here that's within a concrete thing. So what I'm going to do is I'm actually going to take that listener entry one, and I'm actually going to bring that over to, and there's a couple of places we could put this. It's a kind of a tricky one in terms of where we actually store this, because okay, sensor is one of the main things that's making use of it. Perception is also one of the main things that's making use of it. I could set up a common one. It's something where we may change where that actually gets stored. But for now, I think having that listener entry there, because it shouldn't be something where it's referring to the Perception Manager for it. I think that's not ideal. So, okay, we can tick the sensors, but our detection stuff actually needs to decay. That's actually an important part of what we should be doing here, is those detections can actually decay over time. So what I'm going to do is I'm going to create a couple of settings here. So we're going to have a protected float detection decay delay. So this is how old the last detection needs to be for us to start the decay process. And then we also want to have our decay rate. So I have a detection decay rate. So after a tenth of a second, it will start to decay, and then it will fully decay over the period of a second. So, okay, what I can then do is I can then actually check for each sensor, okay, is it time to be decaying it? So there will be a threshold. So age threshold to decay. So that's going to be current time minus our detection decay delay. So then what we can do, stage 2, and this is decay any old detections. So what I want to do is loop through all of our detection data. So var detection KVP in our all detection data. So we have our listener is the key, and then we have our detection entries is the value. So then we need to loop through those detection entries. So we have for each var detection, we'll call this detection data KVP in detection entries. Because what we have with this is we have our perceivable, and that is our key. And then we have our data, which is our detection data KVP dot value. So there's a lot of stuff we're traversing through here, but we're looping through all the listeners, we're looping through all of the data here. Then we need to detect, okay, can we decay this? So if it can be decayed, well, we can know if it's able to be decayed if the last detection time is less than or equal to that age threshold to decay. If it is, then I want to do the actual decay process. So how that looks when we decay these particular ones is what I would say is our data.strength. We do a clamp to 0, 1 of our data detection strength minus our decay amount. Now, decay amount, I'm going to actually define up here. This is our time.delta time multiplied by our detection decay rate. So I just do this logic in terms of pre-calculating it so that although likely it would optimize it out, also just keeps this code a little bit cleaner and neater. So that's the other advantage of it. It just makes it a little bit neater to work with. So, okay, something could have reached the point where it is actually fully decayed at this stage. So if it has, what I want to do is I want to flag it for removal. So if our detection strength is less than or equal to 0, I need to be able to be removing this particular thing. So what I'm going to do is I am going to, outside of the outermost for each loop, is I'm going to create a list here. And this is going to be a perceivables to remove. And this is a new list, and we give it the active perceivables count. So what I would do here is perceivables to remove, add, and the perceivable, and then I just skip. Now the reason I skip is because there is going to be further logic we want to actually do here, because this is actually stage 2 and also stage 3 identify the best detection. So we're going to also keep track of our actual best ones that we've got for each particular listener, so that we can tell the listener, hey, here is your best detection, or here is this detection that's disappeared. So what I would have is our IPerceivable best perceivable is null. We also keep the detection data for it. So our detection data, best detection. So we're doing a couple of things at once. The reason being is, okay, if our actual detection here, we've done and looked for the decaying. So is this a new best detection? Well, it's a new best detection if our best detection or best perceivable is null, or if the data detection strength is greater than best detection strength. So if this is the case, we have a new best one. So we can say best perceivable, it's that, best detection. That should be data. Getting in the word. So, okay, so we're doing a bunch of things at once here. We're going through, we are decaying things, we are flagging ones for potentially for removal. Because we're already traversing the data, at the same point in time, I'm going to look for ones that are actually our best detection. The reason for this is so that I'm not iterating over the data multiple times, because we're looping over every perceivable for every listener that has any detection entries. So that's a lot of stuff we're looping over. So if I can loop it over once rather than multiple times, that's actually a good option. So, okay, we're updating all of that. This, we've looped through all of the perceivables. We've updated these entries. So what I want to look for here is, okay, did we find a best perceivable? If I did, then what I can say is, well, our listener are on notify, best perceivable, and we give it the best perceivable. We give it the best detection strength, best detection the time, and the best detection and the location. Now that's quite a long line of code. So this is actually one where what I'm going to do is split it like this. Just keeps it a lot neater. That's good. So, okay, we found a valid target that the listener needs to be notified about. So, need to notify listener about target. Well, okay, we also could have entries that we need to remove. Are there entries to remove? So we're going to loop through our perceivable in our perceivables to remove. Now what we do is, well, firstly, the listener gets told that it lost that perceivable. So that allows us to ensure that that information is carried through. We also can have our data entries here. We can remove that perceivable. So we can do detection entries and we remove that. And at the end of this, we just clear that. So this allows the listener to notify that it's been lost. This cleans up those detection entries so we don't have ones that are irrelevant. Now, the end result of this is we could actually end up with no detection entries for this particular listener. So we might have a listener that we should remove. So I'm going to have here IListener, listeners to remove, and we just pre-allocate it. So for getting the number of listeners, we can go from our all detection data.count, and that's actually IPerceptionListener. So, okay, if there are no more listeners for this particular one, so flag empty listeners for removal. So this could happen where all of the particular targets that it's listening for are no longer present. So, okay, if perceivables to, oops. So if detection entries dot count is 0, then what we do is we say listeners to remove, and we add that particular listener. We just check where this is happening. So, okay, this is our mapping of that listener to the detection entries. So this just also, removing these keeps it that the data we're churning through stays as small as possible. So that's always a handy thing. So then listener and listeners to remove, we would do our all detection, remove that, and that's done. So clean up any listeners. So, okay, we have set up a lot of stuff. We want to make sure that Unity isn't getting grumpy at us. It's currently not. That's sort of what we should expect, because it's not really got any of this code path actually running yet. We've still got to set up things like our actual listener, our perceivable targets, and our sensors. So there is a lot of infrastructure to this that we are putting together, and that does take quite a bit of time. So that's why I said there will be a second part to this. However, if you're wanting to just jump to the code, by the time this part is live, the code for the final implementation will also be live. It's just the tutorial walking through it will be the week following when this one has come out. So there's a lot of stuff we've set up. It's a huge amount of infrastructure to this, but this infrastructure is ensuring that we have a perception system that is very flexible. We'll be able to easily add in other sensors. It gives us a perception system that we can centrally balance performance, because we can control what things we tick, at what rate we tick them, and we've got that sort of easy swapping in and out of the particular data there. So it's going to, well, it's a lot of infrastructure and a lot of setup. This is giving us a system that is going to be very easy for us to work with in the end. Thanks, folks. Hope you found the video interesting and helpful. If you are looking for the code for the project, there is links in the description below. So as mentioned, there is a link to the code as it was at the start of this video. There is a link to the code as it currently is now at the end of the video, and there is a link to the completed package and project there. If you're wanting to see how other parts of the project were built, there's also links there to the playlist that has for all of the components there of the behaviors package. If you have any questions, chuck those in a comment below. And if you are looking for other ways to support the channel, then I do have a Patreon, and there is a link to that in the description also. But until next time,